Okay, I'm going to record an introduction to Unit 11. So in Unit 11, we're going to do some more exploration of arrays, look at multi-dimensional arrays, two-dimensional arrays, some ways of looping through arrays that are new there, and also searching and sorting arrays. So lots of things we'll introduce here. Um, I'll start by going through this learning material in just a sec, but just a quick overview of the class. Um, We'll do our learning activity on Conway's Game of Life, a famous simulation game here. So we'll go this, but we'll actually see that introduced in the learning materials in just a sec. I'll bring that up. There's a bunch of practice problems again here, and then the assignment this week is on image stacker, which we have a number of blurry images from a astronomy telescope, and we're going to try to put them together into one big, one clear image. So introduces to us to a two-dimensional array and processing through two-dimensional arrays here. So let's start with the learning material here. I suggest we start with the review material here, the readings. Now, if you're still struggling with arrays, I suggest you actually go back to Unit 10 and we'll read through some of that stuff also. Make sure you're there. But if you're, familiar enough, you know how to declare an array, say array of strings, you know how to loop through with a for loop and print out each element in an array, add an element in an array. Maybe if there's an array of integers, sum up all the elements in an array, that sort of stuff. Then you're ready to try to go on to this stuff. We're going to start by looking at an enhanced version of what's called a for each loop with arrays here. Now, I'm going to come back here. One of the things we see a lot with arrays is these loops. We have this loop like here we're setting each element in an array to a random number. And so we're saying for int I equals 0, I less than the length of the array of dice here, and then I plus plus. And then we keep referencing dice, the array sub I here. This is real common for loop with this. We see that like here, we are printing out the array. We're passing in an array of integers here, the parameter, and again, loop for I equals 0, I less than the length, I plus plus, and we're printing out dice sub I. This works very well when we also want to print out something like the index. We want to print out the dice number here, or else the dice number plus 1. Here, we're summing up the values in an array. So again, we have an array of dice. And again, for int I equals 0, I less than the length of the array, I plus plus, and then we're just getting each element in the array, dice sub I here. Because this sort of for loop, we see 3 of them in this one little program, they're so common, we're going to have a special loop just for that called a for each loop. We're going to say for each item in the array here. So we can say like for each value in this array of scores, do something for this. And so this walks you through a couple examples of that. I'm actually going to just do it also over here for this. So let's say we want to sum up all the values in our array here. Rather than doing a for loop like this, I'm going to comment that out. And I'm going to say for each, and then we want to say, so again, let's look back here. We want to say parenthesis, and then the value we want. So for in other languages, it says actually for each, but in Java we say for. Now, each value in an array, this is an array of integers, so we're going to say for each int, let's say value or die, maybe these are die, in dice here. So again, similar here, we say for int value, not in. Again, I've been doing too many different languages. Okay, for int die in, you could read that in dice here. So die will be assigned each value in our dice array. So die will be assigned to dice sub 0, dice sub 1, 2, 3, all the way up to the length of it. So it's kind of, rather than doing this I and saying dice of I, we can say die is going to be assigned to each value here, and then we'll just replace dice of I with die here. And this will do the same thing. This loop and this loop are the same for this. Here, maybe I should show you, again, there's two ways of doing the sum here. One is the old way, dice of I. Here, if you're doing a loop with an index, you say dice of I. If you're doing a for each loop, so for each int die in dice, we read that in dice, then we just use this die. It'll be there instead of dice of I for this. So that's how we set up this sort of loop. Okay, and with all this editing, I ended up with, I think, an extra brace down there. Okay, let's redo that. Okay. Similarly, when like up here for this, we want to do an array, we can do the same thing here rather than saying this. We can just say for int in, or not in, colon dice here for that, and then we can say die is equal to that value for this. So then we say that, and we put our brace here, and then we can just refer to die for this. So this should work out the same way. We can run this, and it should work the same way. Now, one of the problems we have with this is that it will not. We're given a die for each one here. This is not referring to the actual array. So when we're trying to initialize it, it doesn't work here. So this, we can't use it for this sort of initialization here. So we have to actually do this when we're doing initializing array. We have to use this sort of array. But it works fine for finding like the largest or summing up the die. So again, similar here, when we're finding the largest, we have the same sort of array here. We can get rid of that and replace it with a for each loop for each int. Again, it's an array of integers, so we say int, and then we can have some die, or and you can call it whatever you want. I can just say value and in, or we just do a colon in dice. So this will be each element in, or each value in dice. And then again, we can just keep asking if the value is greater than the largest so far. So that the largest so far equal to the value, and return that here. I'm missing a brace. Okay, and so this should print off the largest so far. It'll print off the highest dice and then the sum of the dice. Okay, so this is our for each loop. Now here we have for array of names, strings. So again, the array is called names. So we say for string name in names, so a colon names. So name will be each one, and then we're going to print off each name for this. So this will print off each value and each name in this. A lot of companies will, once you get using this, will require you to use for each loops, and you'll use them a lot going forward here. So while you can start using for loops initially, at some point you want to be moving toward these for each loops, and we'll talk more about them even when we get to array lists next week. There's some okay practice problems with coding here. And then this talks about searching and sorting. We introduced this sort of concept in mobile CSP in CS principles here. So let's just talk a little bit about searching and sorting here. So I suggest you go through this. This talks about what is called a sequential search, just looping through each element in the array and trying to check if some value is some target. So again, let's say we have an array of integers called elements, and we're trying to see if some target value is in the array. Then we're going to loop through the array. Here, we're going to check each element and if it's equal to the target, and if so, we're going to return it, saying we found it. If we don't find it, we're going to have to return something else. A common practice is return -1. Isn't always good, because especially if your array values are negative. So this may be the assumption here is that all the array values are positive, and then you return a -1 here for this. So here you find the value. Another thing to return is, so this returns the index where you found it here. So the index is not going to be negative, it's going to be 0 or positive. And the other thing you could do is you could return the actual element found here. So that's what we're working with here. And another thing to do is to do what is called a binary search. If your elements are in order, scroll down here, we can do a binary search here. And again, if you remember back to CIS principles, we talked about, like, if you're told if a number is larger or smaller than you're guessing, it's easy to narrow things down. So if I say, I'm thinking a number between 1 and 100, can you guess it? You might start guessing 50, and I will say, it's less than that there, or it's greater than that. And you'll get, okay, if it's bigger than that, I'm going to guess 75, and I'm going to say it's less than that. Then you know it's between 50 and 75, and you'll guess some number in between, right in the middle of that. So every time you can be dividing this in half with this binary search. This kind of shows a visualization of the binary search here. And we can write out the binary search. We're not actually going to go through that algorithm. To tell you the truth, you should never probably be writing your own binary search. Binary search is built into all important array elements and stuff. It's already there generally. So there should be a way of doing a binary search on your elements for you for that. But you can look, if you're interested, you can look at that. Again, we're keeping track of is the left and the right element that we want to guess there. So we're starting at the left is 0, the right is the length of the array, basically, and we keep going until the left is should be less than the right, unless we never find it. Here we find the middle spot, and we check if the middle spot is what we want there. If our value is too small or too big, we move either the right or the left over to the middle spot, plus or -1. And we keep doing this value looping again and again for this. If we find it, we just return the value we find. So let's look at this here. It talks about the runtime, how long it takes here. So how many comparisons? So if we have 100 elements, it could take up to 100 comparisons to do that, where a binary search only takes 7 at most for this stuff. So again, you might want to look through that. That's an interesting one. And then sorting. There's a bunch of sorting algorithms out here: selection sort, bubble sort. And again, we talked a little bit about sorting. Again, when we are in CIS principles, we look at different types of sorting algorithms. So this is good to look at. But I'll just warn you that, again, you can never be writing your own sorting algorithm. You should always be using one of the built-in fast sorting algorithms that built into these languages and have been tested and proven to work. It's very common to write searching and sorting algorithms that you write them on your own to miss edge cases or strange conditions there, or to get something wrong. So I generally suggest you should be using pre-written searching and sorting that's built into all of our classes here. We'll get to that when we go a little bit further. Okay. Next up, we're going to look at, you might want to start looking at these two-dimensional arrays. We'll bring this more when we talk about our our assignment this week. Now, Java doesn't have what we call a classical two-dimensional array where you actually reference it and you say 1, 1 or something like that. Instead, we have what is called an array of arrays there. So we can declare an array of arrays, which works like a two-dimensional array. And then we can say, oh, the first value is going to be the row and the next value is going to be the column, or vice versa, whatever you agree upon. You declare the array for that size, and then you can refer to it. And so it's referred to one index and the other. But what this is actually is what we call, like what we utilize it is a two-dimensional array, but it is actually an array of arrays here. And so again, think Java just introduces these as arrays of arrays, and they introduce it with something called Conway's life. And this is what we're going to be doing in a learning activity there. So I would certainly recommend you review Conway's life here, get to know it. Again, you don't have to know all of this. We're just going to see some of it stuff. And this is probably more than what you want, but this shows you how Conway's life is actually implemented here for this. So if you're interested, we're just going to be programming some parts of it. So that's some readings to do. There's a couple interesting examples of passing arrays as parameters here. This is the first one here where we're passing an array as a parameter. Let me just go over here and do a new project. Unit 11, sandbox. And I'm just going to grab this main and paste that in here. So let's look at this and passing arrays as parameters. We've already seen this a little bit, but this goes over it again. So here we have an array called products, and it's an array of strings. And we're going to print out that array, and we're going to pass products to this array. So again, this is a parameter, an argument in this method, so we can just put it right there. Now, how do we declare it? This is called print array one, print array run. And again, we just say what type. It's an array of strings, a string square bracket, and we're giving it some name. It doesn't have to be the same name as up here. This product array will be passed down to this array value. And then we will loop through this array here and work on each element. Now, inside the loop, we're using not products, but we're using array. And here's our for loop, looping through each index. Now, you said, I thought, Tom, we weren't going to use those as much. And yes. So here's print array 2. Again, passing the products in. Here's print array 2, similar parameter here. And here's our for each loop. One thing look how simplified this for each loop is and this statement is. This whole loop, how simple that is compared to this more complex one. That's one thing nice about those for each method or stuff. This shows does a linear search to here and passes an array and a target down here. So yeah, you can pass arrays as parameters. Here you can pass array of strings. Here's an example using we're passing an array where do things like of doubles. Here's to print an array with an array of doubles, and we're printing off each value here. And here again, we're using this for each construct. Here's the find largest value here. Now here we're not using a loop because we're returning we're returning large values. So again, this could be done with a for each loop here because we're returning the largest value. Here's find smallest, and here's the total. And again, this total is using a for each loop in this case. But we're always, again, passing these in as a parameter for these values. Okay, so feel free to do that. Now, so in class, in next class, we're going to do this poll activity here. I suggest you might, if you want some more examples of arrays, especially 2D arrays, Chris walks you through this lab grade with parallel arrays here, and then with a 2D array here. So these are some good videos to watch as we review things. Okay, let's wrap this up.